So for our first example, we have c is the portion of this parabola y equals x squared going from 0 to 1, and fxy is just 2xy. And so I want us to work out this line integral in two different ways. So maybe we'll start just by sketching a little picture of what's going on here. Whoops, that wasn't very nice. We're going to go along x squared from 0, 0 up to 1, 1. And I want us to do it directly and then go back and use the theory that we've been learning as well. So let's do it. Here we go. So this is going to be, for the first way, we need to go ahead and work out a parameterization. The classic approach is you have to have a parameterization for your curve. I want to start here and go there. And so to parameterize that, if you're given an equation where you have y as a function of x, an easy way to parameterize that is just r of t. You set x equal to t and y equals to f of t. So t squared, and in this case, letting t run from 0 to 1. Wow, that was bad. 0 to 1 does the job just fine. So there's my parameterization. How do you come up with that? Again, if you're given y as a function of x, and you just set x equal to t and y equal to f of t. That's one way to do it. There may be other ways as well. All right, so I've parameterized this thing. I probably should compute the gradient. Let's just dive in and see what we can do here. So the line integral of the gradient of f dot dr is the integral from 0 to 1 of the gradient of f, and we'll work that out to the side. Let's do that in pink up here. The gradient of f is going to be what? 2y comma 2x, right? That should be clear to you. So I'm going to take my parameterization and I plug r of t into the gradient, and I'm going to do that right here now. So 2y, well, y is t squared, so I get a 2t squared comma 2x, x is t, so 2t. And then I want to dot with r prime, which we can just compute in our heads. So 1, 2t, and then I want to evaluate that. So I get the integral from 0 to 1 of 2t squared plus 4t squared dt. This is just 6 integral 0 to 1 of t squared dt. And I actually remember from Calc 1, this is the one integral that I work out as a Riemann sum, and so I know it by heart. It's just a third, so you're actually going to get 2. So we solved the problem. It wasn't that bad, really not a big deal. Let's see if we can use the fundamental theorem of line integrals to help us. On this problem, it wasn't bad to do it directly, but you can imagine pretty easily that other problems it might be really hard to do it directly. So here's how you use the theorem. The line integral along c of the gradient of f dot dr. This is just f of the endpoint. So f of r of 1 minus f of the beginning point, f of r of 0. We know r of 1 is 1, 1, so this is f of 1, 1 minus f of 0, 0. And f of 1, 1 is 2 times 1 times 1 is 2 minus 0, so this is just 2. And really, this was a lot easier. Even though this problem wasn't that bad, the fundamental theorem makes it significantly easier. So let's end this video here, and then we'll keep going in just a minute.